instead of going through the whole proof and the definitions that they're trying to confuse your brain with, basically derivatives and integrals of trig functions are super simple because everything relates to two things: sine and cosine. What is tangent? Sine over cosine. What is cotangent? Cosine over sine. What is secant? Remember, it can't start with the same letter. And then cosecant. That's the only way I remember it. It can't start with the same letter. So everything breaks down to sine and cosine. And sine and cosine relate to the unit circle. These are the points of interest. Because we know that's 0.10. This is 0.01, -1, 0, 0, -1. Cosine x is the x component. Sine x is the y component. So that's cosine x, sine x. This is cosine x, sine x. We don't care about the parts that are zero because they don't contribute much to anything. So on this one, at this point, it's cosine. At this point, because that's one, it's sine. At this point, it's negative cosine. And down here, it's negative sine. This is where it gets simple. I'm gonna show you now how to do both derivatives and later on integrals. So I'll show you all right here. It'll take you a better part of 5 seconds to memorize. The derivative of trig functions goes this way. That's the derivative. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative cosine is negative cosine, and so on and so forth, forever. That's derivatives. Integrals go backwards. That's the integral. We'll get to that later on in this course. So there you have the trig identities. Let's look at example 1. A. Y is equal to x squared minus sine x. What is y prime? So 2x. Yeah.
It just goes opposite from wherever it's on.
No, you keep on going clockwise around it.
Sorry.
Yeah. You're going all the way around. So the derivative of sine is cosine, already negative. B, y is equal to ex sine x. So what rule are we going to use here? It's multiplication. So what rule is that? The product rule. And the product rule, remember, we have to use the f, g, f prime, g prime. So f is e of x, g is sine x. What's the derivative of e to the x? Yeah, it's e to the x times the derivative of the exponent, which is 1. The derivative of sine, cosine. So start in quadrant 1, we have sine x times e of x, so we have ex sine x, plus, since it's a product, e of x, the cosine x, so it's ex cosine x. Or you can factor out what's in common. And there's your derivative. Of course, we have to do quotient. Same thing. You have to do the f and g, f prime, g prime. So it's sine x over x. The derivative of sine x is cosine x. Derivative of x is 1. Again, it's always a fishy, but since we're dividing, we have to subtract because we're making things smaller. Remember, what happens to the bottom number always? It becomes squared, right? Whatever's on the denominator of a quotient rule, always squared. So we have x times cosine minus 1 times sine x. And there you have it. Difficulty level? As long as you memorize this, x is the cosine values, y is the sine values. Example 2. A, y is equal to 5e to the power x plus cosine x. Find y prime. So the derivative of 5e to the x is? That's a constant multiple, so leave it alone. Derivative of e to the x is e to the x times the derivative of x, which is e to the x. Derivative of cosine, negative sine. And there's your answer. Sine x, cosine x. So sine x, cosine x. What's the derivative of sine x? Cosine x. Derivative of cosine? Negative sine x. Yes. That's why whenever you do trig identities, don't be ashamed to write that down. Sine, cosine, negative sine, negative cosine. It's just 5 seconds. It'll stop you from making mistakes, and you're going clockwise. So we have to use the fishy. Since we're doing product, it's a plus. Cosine times cosine is cosine squared x. Since it's a plus. Sine times negative sine is negative sine squared x. And that's your answer. Cosine x divided by 1 minus sine x. Cosine x, 1 minus sine x. Derivative of cosine, negative sine. Derivative of 1 minus sine x, minus cosine. Yeah, because the sign in front doesn't change. It would have changed if this was negative cosine, it would be positive sine. So we're dealing with this, so it's a minus. So we have y prime. And the bottom is squared. So we have negative sine x times 1 minus sine x minus cosine times negative cosine, which is negative cosine squared. Let's get rid of the parentheses. We have negative sine times 1 is negative sine x. Negative times negative is a positive. Sine x times sine x is sine squared x. Negative times negative is a positive. Cosine squared x over 1 minus sine x squared. We have negative sine x. What is sine squared x plus cosine squared x? 1. We can rearrange those. So one of these cancels with one of those, and we're left with that. Y'all feel comfortable, kind of confident with it? Because if you wanted to, we could do tangent and cotangent and all those other derivatives. Simple harmonic motion. Have you ever heard of that before? That's springs, harmonic motions. Example 3. It says a weight hanging from a spring is stretched down 5 units beyond its, so let's here we have 5 units or -5 since we're going down. This one is 0 and this one's +5. Is stretched down 5 units beyond its resting point. So this is its resting point. And released at time t equals 0. So this is position at time t equals 0. To bob up and down in the position right here. Its position function is given by this. What are its velocity and acceleration? At time t. So how do we find velocity? The derivative, yeah. So we got to take the first derivative of our position function. So what's the derivative of 5 cosine t? -5 sine t. The coefficients stay there. What is acceleration? It's the first derivative of our velocity. So our coefficient is -5. What's the derivative of sine? Cosine. And there we have it. What is the jerk? Which is the acceleration derivative of acceleration. So we have -5. What's the derivative of cosine t? Negative sine t. So negative and negative make it a positive. Example 5. If your function is tangent t or tangent x, find the first derivative. So what do we do first? The first thing you have to do is rewrite that in terms of sine and cosine. Now we have a quotient problem. So it's sine x over cosine x. Derivative of sine x is cosine x. Derivative of cosine, negative sine. Since it's a division, we subtract. So, and the denominator is cosine squared x. We have to square the bottom. So we have cosine times cosine is cosine squared x minus sine times negative sine is negative sine squared x. Cosine squared x plus sine squared x over cosine squared x. Cosine squared plus sine squared is 1. 1 over cosine squared is secant squared. That's how we do the rest of them. Once you break everything down to sine and cosine, it's just use the basic rules. Let's try a second derivative. Example 6. Y equals secant x. Find the second derivative. First thing we do, how do we put that into sine and cosine? What is secant? 1 over cosine. So we got to find the derivative of that one. F G F prime G prime. So 1 cosine x. Derivative of 1 is derivative of 1, 0. Derivative of cosine, negative sine. Since it's a quotient, we subtract. All over cosine squared. Cosine times 0 is 0. Minus 1 times negative sine is negative sine. Is equal to sine x over cosine squared x. But let's rewrite this into terms we know. This is sine x over cosine x times cosine x, which is sine x over cosine x times 1 over cosine x, which make it, what is sine over cosine? Tangent, what is 1 over cosine?
See,
So that's the first derivative. Now it's going to get a little bit hairy. But it doesn't have to. Because once you have done something, you can always refer to it. The second derivative will be this product. So we have tangent and we have secant. Do we know the derivative of secant? Just look half an inch higher on your piece of paper. We just solved it. Tangent x secant x. And we just also just did tangent too. The derivative of tangent was secant squared x. Since it's a product rule, we're going to add those two. So secant times secant squared is secant cubed plus tangent times tangent is tangent squared secant x. And there's your answer. It's just a matter of plug and play. Again, you have to pay attention and you have to think about this stuff. You can't be distracted when you do this kind of stuff because one loss of thought, you're gonna get in a place you don't want to be. What if we had the limit as x approaches 0 of square root of 2 plus secant x over cosine pi minus tangent x? Remember, the first thing you want to do whenever you have a function, a limit function, as x goes to some place, is do what? Plug it in there, see what happens. So we have 2 plus secant at 0 over cosine pi minus tangent at 0. What is secant at 0? Secant, remember, was 1 over cosine. What is cosine at 0? 1. So secant is 1 over 1 is 1. So the top is square root of 3. Tangent at 0. Tangent is sine of 0, cosine of 0. What is sine at 0? What is cosine at 0? So it's 0. So it's minus 0. So we have radical 3 over cosine at pi. What is cosine at pi? -1. So your answer is negative radical 3. If it works, it works. If it doesn't, it doesn't. All right, that's it for that. I hope you thought that the trig functions were not that difficult. A lot of people are worried about trig functions. No, it's just once you relate everything to sine and cosine, it's a breeze. Much